The decimal representation of rational numbers, that is terminating and non-terminating decimal representation. What is terminating rational number? Like say 2 by 4 equal to 1 by 2, that equal to 0.5. Clear, terminates. Certain numbers like 1 by 3, 3, 3, 3, and it goes on. This is a non-terminating rational number. So what is the decimal form? We will take one after other. Here let us take 3 by 4. Decimal form of 3 by 4 we know is 0.75. Okay. How did we come across this? We divided 3 by the number 4, and it's remainder 2. Bring this 0 down, then it becomes 0, so it is 0.75. The second case, the decimal form of 5 by 8. How do we find that out? Okay, 5 by 8 is the rational number. 5 divided by 8, we do 5 inside, divided by 8. So 8 doesn't go inside, so we draw 0. Then since we club the decimal point together, we have to start with the decimal point. 50 minus 48 is 22, and bring this one more 0. You can add any number of zeros. Okay, so when we represent 5 by 8, how do we represent it? 0.625. Wait, this is terminating. Look, what is the decimal form? 7 by 5, 7, 2 left. 5 doesn't go inside 2, so add 0, but put a decimal point, right? You know how to do the division. 0, so terminating 1. So 1 by 5 can be represented as 1 by 0.4. There is another important point that needs to be mentioned here. The rational number is of the form p by q minus p by q, p by minus q. You know what it means here. The negative sign comes into picture, right? So what we do, there is negative sign, we just find it like p by q. Example is minus 1 by 4, okay, or minus, we can call it 2 by minus 8. Okay, for this first we find 2 by 8 and then add a negative sign. That is what is told. So for example, minus 3 by 4. First find 0.75. We found that it's 0.75. Then we added the negative sign. Okay. Same case here. 5 by minus 8. We know the answer. We found it above. It's 0.625. Then we added the negative sign. Same way here. Okay. 7 by 5. Finally, it's going to be 1.4. Okay, then add the negative sign. That is the idea. So don't worry about the negative sign now. First do the division, then add the sign. Now we talk about the terminating and non-terminating decimal representations. Terminating means it stops, where repeating, and the non-repeating. As before we saw, 1 by 3 is a very good example, where the 3.3 goes on repeating, right? So instead of keep writing like this, we use the term dash on the top. Okay, so that means this guy goes on and on and on. Okay, same way, 2 by 9, do the division. Okay, that is divide 2 by 9. Okay, 0 2 times, it goes on and on and on and on and on. Okay, so this guy can be represented as 0.2, and the dash says what? 2 2 2 2 2. This goes on and on and on. That is what it says. Okay, 2 by 11, we get, try that out. Okay, 0.1818, like this is the number alternatively repeats, right? So this is called, if this repeats like this, then we indicate it like this. That means what? It goes on like what? 1 8 1 8. Two numbers keep on repeating it. That is called, that's how we denote it by a dash with two numbers on it. Okay, you do the math here and tell me. Let's take the third case, 1 by 7. Okay, when we divide and see and represent it in the decimal fraction way. Look at this. Divide 1 by 7, so we get 3. Then bring the 0 down, bring one more 0 down. This is how we go on doing it. We can add any number of zeros and the numbers, but the set of 6 numbers repeats here. You see this one? After the 6 numbers, 1, 4, 2, 8, 5, 7, this guy goes on repeating. What will happen? If we have one more set, it would be 1, 4, 2. All the 6 numbers repeat in this case of 1 by 7. When we say the bar over that, means the entire set is repeating. Okay, going to recur. What is recur? Recur means reoccur. Okay, keeps coming. Yes. There is some speciality in this 3 rational numbers. This can be represented as 2 to the power 2. 4 can be represented as, right? 8 can be represented as 2 to the power 3. 5 can be represented as 5 to the power 1. Something like that. What is good thing about this is, if we convert the denominator into 100 or 1000, then we know that it is going to be terminating 1. If we take 10, then it is going to be 0.2. So terminating decimal, right? So we can make this denominator into a 10 to the power something, so that 10 to the power 1 or 2 or 3 depicted in a fraction in a terminating way, right? So look at that. So 5 by 8 is what? 2 by 3. So if we multiply by 5 to the power 3, 2 to the power 3 and 5. So we can multiply 2 and 5. This is equal to what? 10 to the power 3. Likewise, if it's 2 square into 5 square, equal to what? 2 into 5, 10 to the power 2. That is 100. So 10 to the power 3 is what? 1000. So likewise, if it is the denominator is 5, or any powers of 5, like 5 to the power 2 is what? 25. 5 to the power 3, 125, like this, if it goes. Okay, here in this case it is going to be what? We can multiply it by 2, hence this becomes 10 to the power 1, right? So when you multiply by the denominator, you have to multiply the numerator, so this gets cancelled, but we use it to bring a denominator to 10 power something. Okay, so 2 sevens are 14 by 10 is 1.4. So let us take another 3 rational numbers which does not have 2 or 5, multiples of 2 or 5, like 3, 2 by 9, the denominator is 9, 2 by 11, denominator is 11. This cannot be converted into some numbers of multiples of 10, right? So something like 11 can never become 100, 1000 or whatever, right? So one problem is, if you look at that kind of a thing, this cannot be converted into some multiples of 10. These become repeating fractions. Like 1 by 3 is what? It goes 3.33333. Hence, we come to a conclusion that anything which are different from 2 and 5 in the denominator, multiples of 2 and 5, we know that, okay, we can come to a conclusion that these things are not repeating fractions, rational numbers, right, when we depict it in the decimal form. But these rational numbers can be written in 2, which has 2 and multiples of 2 and 5, they can be converted into multiples of powers of 10.